Hey everyone, welcome back. Ready for another deep dive?
Absolutely. Always excited to explore something new.
Well, today we're getting into the world of metallurgical engineering.
Oh, cool.
Our listeners sent in some seriously interesting stuff about three big innovations happening in the field. And you know what?
What's that?
They're all about learning things quickly and thoroughly. So we're going to break down these innovations, additive manufacturing, high-throughput experimentation, and computational material science. But before we get too far,
Yeah.
quick reminder, metallurgical engineering is all about how we get metals, how we refine them, and turn them into, well, all the metal things we use every day.
Right. And it's not just about making the process better. It's about pushing the boundaries of what we can even do with metals. It's
Yeah.
pretty amazing.
Totally. Okay, so let's start with additive manufacturing. Most people know this is 3D printing, right?
Exactly.
And I have to say, the idea of 3D printing with metal, that's just wild to me. It sounds like something straight out of, Star Trek or something.
It may have seemed like science fiction before, but it's definitely a reality now. And what's really revolutionary about it is how it works. It actually builds objects layer by layer from a metal powder.
Wow.
Yeah. And this allows for some seriously intricate designs and complex shapes that you just couldn't achieve with traditional methods like casting or machining.
So it's not even just about the speed, it's about unlocking totally new possibilities for what we can even design in the first place.
Absolutely. I mean, think about it. This means we could create things like medical implants that are custom fit to a patient's body down to the millimeter, or super lightweight but crazy strong components for airplanes, which would have been impossible to make before.
That's incredible. It really feels like additive manufacturing is opening up a whole new world of possibilities. But you know what else is really speeding things up in metallurgical engineering?
I bet you're going to say high throughput experimentation.
You got it. And this one, it makes me think of those cooking shows where they have like a whole wall of ovens going at once, testing out tons of different recipes.
Haha. Yeah, I see what you mean.
But in this case, instead of cookies, we're talking about different metal combinations, right?
Exactly. That's a great analogy. High throughput experimentation lets scientists test out tons of different alloys super quickly. And they can change up the composition, how it's processed, all sorts of variables. It's like a fast forward button for discovering new materials.
So instead of taking years to fine-tune things and run a bunch of separate experiments, researchers can now explore thousands of possibilities in way less time.
Exactly.
And I bet this is a game changer for industries where finding the right material is like the key thing, right? Like, for example, developing better batteries for electric cars, or maybe building materials that are way lighter and stronger.
You nailed it.
Oh.
And, it's not just about the speed. High throughput experimentation creates a ton of data, a mountain of it, and this data can then be analyzed using, drum roll please,
Computational materials science.
bingo, you're on a roll.
Okay, so this is where things get really futuristic, right? It's like we're stepping into a virtual laboratory where scientists can experiment with materials before even touching a single piece of metal in the real world. Tell me more about how that works.
It's pretty mind-blowing, honestly. Computational materials science uses super sophisticated computer models to predict how a material will behave all the way down at the atomic level.
Whoa!
Yeah, it's pretty wild. So scientists can basically run virtual experiments. They can try out different compositions, different structures, different ways of processing the metal, and they can see what works best without having to go through all the time and expense of making it and testing it in the real world.
I could see how that would save a ton of money and time in developing new materials. In fact, I was reading about how they're using computational materials science to design these new types of alloys for jet engines.
Oh, right.
And these alloys are stronger and lighter, which means less fuel consumption for airlines. And that's great for everyone, right?
Oh, absolutely. It's a win-win. And it's a great example of what's possible with computational materials science. The possibilities are just, practically endless.
It's amazing. And when you think about all three of these innovations, additive manufacturing, high-throughput experimentation, and computational materials science all working together,
Yeah.
it feels like we're entering a whole new era of like customized materials designed for very specific purposes.
We are. It's a really exciting time for metallurgical engineering, that's for sure.
And it makes you wonder what the future holds, you know?
It really does. Like, what metal creation that seems impossible now might be totally achievable in, say, the next 10 years? What will our metal world even look like then?
Those are some really thought-provoking questions. Something for everyone listening to ponder. Thanks for joining us on this deep dive. It's clear that the future of metallurgical engineering is bright, and honestly, I can't wait to see what incredible breakthroughs we see next.
Me too. Thanks for having me.